of factoring. Application of factoring. There are many. In this case, is solving equations by factoring, of course. Okay. First, we have to talk about something called the zero product principle. Zero product principle. What is the zero product principle all about? The zero product principle says that if I have any number of factors, as many as you want, a product of any number of factors set equal to 0, this implies either the first factor is 0, or the second factor is 0, or the third factor is 0. So we have 3 possible solutions. But the thing is, how do I get to this situation? By factoring. Good. So now let's take a look. So at the bottom on page 2, I should say, on page 2 of this document, we have the principle of zero product, or the zero product principle, and we are asked to solve several equations. Let's start with the first one, in which we have x minus 2 times 7 minus 4x equals 0. In this particular case, the work is done for us. We do have a factor and we have another factor. By the zero product principle, or the product of zero principle, whatever you want to call it, then we have 2 options. If option 1 is 0, then we get x equals 2. If option 2 is 0, then we get x equals 7/4. So this equation has 2 solutions. One solution is x equals 2, and the other solution is 7/4. But again, the work here was done for us. We didn't have to factor. The whole equation, or the left-hand side, if you want, was already factored. Good. Any questions on this? Okay, moving on. The next one, x squared equals 100. Notice something very important here. The zero product principle requires on one side to have a product, and on the other side mandatory 0. I cannot use the zero product principle unless I have 0 on one side. But in this particular case, I don't. So I will move first 100 to the other side. I have the 0 on one side, but then I have to change this into a product. According to the strategy of factoring, I'm looking at this. It's in descending order. Greatest common factor? No. Negative leading coefficient? No. It's a binomial. Special product? I always hope for a special product. So then, if it's a special product, it's a difference. So it can be the difference of squares or the difference of cubes. Which one is it, if it works? Yes, because it's a difference of squares. Then I have to prepare 2 binomials, one with plus, one with minus. And what are those?
X plus 10, x minus 10.
Very good. So therefore, if the first factor is 0, then I get x equals negative 10. If the second factor is 0, then I get x equals 10.
So for principles of, or zero product principles, it's always at least 2 answers? Maybe 3?
I would say at least 2, yes. Yes. But it depends. It depends on the problem. Good.
Great.
Any questions on this problem? Anybody? Okay, we move on. The next one, 4x squared. 4x squared minus 18x equals 70.
Minus 70 from both sides.
That's the first thing, 4x squared minus 18x minus 70 equals 0. Now, because this is an equation, and I see that all these terms can be divided by 2, I will divide them by 2. Never divide by the variable. Do not say in a particular equation, oh, divide by x. No, 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 no. You can only divide by numbers. So I'm allowed to divide by 2, and I get 2x squared minus 9x and minus 35. And 0 divided by 2 is also 0. So I can always simplify an equation like always, but not dividing by variables. That is not allowed, ever. Because then you're missing another solution, potential solution. Okay, perfect. So now, I started strategy. Descending order, yes. Greatest common factor, I already factored or simplified that too. Now, when you factor, you cannot divide. So if I am given this, 4x squared minus 18x minus 70 to factor, I cannot say, oh, I'm dividing by 2. No, 2 has to stay as a factor. But if you solve the equation, you can divide by a number. But if you're simply factoring, you cannot remove a factor by saying, oh, I'm going to divide by it, because it's not an equation. This is not an equation. In an equation, we are allowed to divide both sides by a non-zero number. Good. So now, again, the strategy. Descending order, yes. Greatest common factor, no. Negative leading coefficient, no. Trinomial. Special product, no, because this is negative and this is not a perfect square. 1 is the leading coefficient, I wish. So this is the last chance I have to factor. So then I have to find 2 numbers whose product is and whose sum is. Anyone remembers how we determine the product and how do we determine the sum?
So it's negative 70 because they're negative 35.
Yes, yes, and this is negative 9. The sum is always this, but when the leading coefficient is not 1, then we have to incorporate it in the product. But the sum never changes. If the leading coefficient is 1 or otherwise, the sum is always the same. Good. So now we have to think. Now here's my thinking process when it comes to this negative 70. I take 70 on the side. And as we know, it's divisible by 2. So then I have a 35. And I know that this is 5 times 7. And looking at these, I will be able to mix and match them so remember, if the product is negative, then we know the numbers have to be 1 positive and 1 negative. And the negative 1 has to be more powerful because the sum is negative. Again, the thinking process starts with the product. The product is negative, therefore, the 2 numbers have to have opposite signs. Now, because the sum is negative, this must be stronger to overtake this and be negative and get a negative answer. So let's crunch these 3 numbers in some way so that the sum is negative 9 and the product, when you use all of them, the product is there. How do you crunch them and put 2 numbers using all these? Put 2 numbers here whose sum is negative 9.
Negative 14.
Exactly. So negative 14 and 5 is the correct answer.
That makes so much more sense. Like making the prime numbers.
Yes. I do that with the large numbers. Now, if it's 12, it's really not, but when the larger the number, the better write or present the tree factorization.
So you got negative 14 from the 2 and the 7, right?
Yes, so this was 14, and this was the 5.
Okay. Yeah,
So now, remember what we need to do. There's a lot of work to do here. 2x squared plus 5x minus 14x minus 35 equals 0. We need to determine the greatest common factor of the first two,
Which is x.
which is just plain x. Allow me to remove all these because all the videos are uploaded. Just 1 second. 1, 2. Because I don't want to have a glitch a little bit later when it tells me that it cannot record. Okay, they are deleted. Good, excellent. So this is just x, and then we have 2x plus 5. Remember, this is the best method that I rarely say that my method is the best. I always say it's one of them and you choose. But this is absolutely mandatory to write because then you may factor out something else. Who knows what comes up? And you don't write the correct factor. Always write it and then look. We always need a sign and a factor.
It's negative 7.
Perfect. Negative 7, indeed. Remember now we are removing the common factor, which is 2x plus 5. What is left in parentheses when we remove the 2x plus 5?
X minus 7.
X minus 7. It takes a blink to verify. Please always verify. 2x times x, 2x squared. Negative 14x plus 5x is negative 9x. And 5 times negative 7 is negative 35. Now I finally have reached the point in which I apply the zero product principle. Only now I can apply it. When the first factor is 0, I get x equals negative 5 halves. When the second factor is 0, I get x equals 7. And these are the solutions. Any questions? Any questions? Okay, moving on. And I will also show you how we check. Now, more than what we just did. Question for you. What was the degree of this polynomial? Oops, sorry. What is the degree of this polynomial?
3. Sorry, 2.
2. Therefore, we obtained how many solutions?
2.
2. Please keep that in mind. We're moving on.
Will that always be true?
Absolutely. Yep, absolutely. Real or imaginary doesn't matter. So here's the next one. 2x cubed minus 50x equals 0. Now I'm going to ask from the beginning, what is the degree of this polynomial?
3.
How many solutions?
3.
Good. I see from the very beginning, I don't care what it is, I can divide both sides by 2 to make it easier. So then I have x to the third minus 25x equals 0. This divided by 2, this divided by 2, 0 divided by 2. And now I start my strategy. It's a binomial. It's in descending order. Greatest common factor, no. Yes, yes. Greatest common factor, yes, which is?
2.
Which is?
Oh, 2x.
No, we
Oh,
already,
right.
x indeed. What is left in parentheses? Remember, I have two terms. I have to have two terms in parentheses. So,
That's
X
x squared minus 25.
good. Special product? It better be. I love special products. They're the easiest.
It's a difference of squares.
Very good. If we say the difference of squares, then we have to get two binomials ready.
It's x minus 5, x plus 5.
In any order. So then I have three solutions. X equals, x equals, x equals. Can anyone give us those three solutions?
X equals 0.
Exactly. If the first factor is 0, then x equals 0.
And then x minus 5 equals minus 5. And x equals plus 5.
That's it. In certain situations, you may be asked to present the solutions like this. -5, 0, 5. This is the set builder notation. Set builder. Actually, it's not the set builder. The set builder is this. I'm sorry. With this, listing the property. I can present the solutions like x such that x cubed minus 25x equals 0. I can present it like that. But this is just a raster rotation. Raster. The set builder notation emphasizes a property. So it's x, the solutions is x, solutions are x that make this equal to 0. Let me erase the arrow because it's not correct. Good. Do we get the idea behind the zero product principle?
I do have a question.
Please.
That set builder notation, that's you're basically finding the domain.
We use the set builder notation in presenting domain. That is true. But in this case, it's not the domain. The domain refers to what values x can take for a function to exist.
Oh, okay. Thank you.
Perfect. Okay. Now you can say, you may fall into the trap and say, oh, I have a product. Oh yeah, that's nice, but you don't have 0 on the other side. So this makes no sense. I mean, that doesn't mean anything. I have to distribute first, subtract 7, and then refactor the whole thing. So a squared minus 5a plus a minus 5 minus 7 equals 0. And this is a squared minus 4a minus 12 equals 0. And now I have to factor this in order to get to use the zero product principle. Because it's not applicable here. Descending order, trinomial, no greatest common factor, no negative leading coefficient, no special product. This is a perfect square, but this isn't. 1 is the leading coefficient. Yes, at least that. So now we know that the sum is -4 and the product is -12. Sum is -4 and product is -12. Remember, we always start with the product and we say, oh, the product is negative. Well, one has to be positive, one has to be negative, and the negative one has to be more powerful.
2 and 6.
2 and 6. So 6 is negative, so 2 and -6. So we have a minus 6 and a plus 2. You should always take a moment and check. A squared plus 2a minus 6a, negative 6 times positive 2. So then we know these two solutions are a equals and a equals. What are they?
Uh, 6 and negative 2.
6 and negative 2. From the beginning, we expected two solutions because the degree is 2. So that's also the first application of the degree. The degree tells us how many solutions an equation will have, always, if it's a polynomial. Okay, let's also look at this one, H. And then we can, so this will be the end of Mod 6, and we can go and practice now. So 1/2 x squared plus 5x plus 25 over 2 equals 0. Okay,